All right, here we go. First day of notes for geometry. Woohoo! All right. So, again, I'm sorry I'm out today. I will be back on Thursday, which is tomorrow. And you can ask me questions on this on Thursday or Friday, okay? Remember, your assignment from today will be due on Friday, though. So if you do have questions, make sure you come and ask me about the assignment tomorrow at some point. All right, here you go. Inductive reasoning and logic notes 1.1. What is inductive reasoning? Okay. You might need to write a little small for this. Okay. Again, I think I've already said that, but just in case I haven't, make sure you're writing small so everything fits. So inductive reasoning is the reasoning that uses a number of examples to arrive at, if you want to do the at symbol, you can, or you can say at a conclusion. Okay. So a reason that uses number of examples to arrive at a conclusion, okay? And then what is a conjecture? A conjecture is the concluding statement. Okay, concluding statement. Sorry, I have awful handwriting. So concluding statement reached by inductive reasoning. All right. So what you're going to do is you're going to be given a whole bunch of examples. I'll say come up with a conjecture based off these examples, okay? Inductive reasoning is just any thought process you have of what you came up with. So, again, examples, writing conjectures. Write a conjecture that describes the pattern in each sequence. Then use your conjecture to find the next item in the sequence. So let's see. I go to the movies and the show times are at 8:30, 9:45, 11, and 12:15. What do you notice? Remember, 12:15 p.m. is the afternoon, not the morning one. Or the night one, whatever your brain thinks says, nighttime, daytime. Okay, so what is the conjecture and what is your reasoning behind it, okay? My inductive reasoning is that these two are how many minutes apart? An hour and 15. So that is how many minutes? 75. Okay, what about 9:15 to 11:15? Or sorry, 9:45 until 11. That is also, if I do an hour, that'd be 10:45 plus 15 minutes is 11. So these are also 75 minutes. So that means these should also be 75 minutes, which is true. An hour later would be 12 plus 15 minutes. Those are all 75 minutes, right? So if I said, come up with a conjecture, what would your conjecture be, okay? My conjecture would be movie start every 75 minutes at this movie theater. Oh, what am I doing? Look at my handwriting. Okay. So again, we looked at our information that was given. We said, okay, these movies are happening every 75 minutes. So movies must start every 75 minutes at this movie theater. All right. Try to come up with the next one. So it gives you all these blocks, which are kind of funky. If you want to draw lines, you can. But you notice this one goes from 4 to 10, okay? So what could you do? You could say, what's the difference between 4 and 10? I take 10, subtract 4, I have 6, right? Let's see if that's true for this one. How do I go from 18 to 10 or 10 to 18? Is it 6 again? No. To get from 10 to 18, we either had to add 8 or subtract, right? to find the difference between them. Okay, so there's a difference of 8 between them. The word difference means subtract. So if I take the two numbers and subtract them, that's what's left over. Okay, how do you get from 18 to 28? You add 10. Okay, so 28 to 40, that would be 12. So you need to come up with conjecture now based off the information given. What can you figure out? What's your reasoning behind what your statement's going to be? Okay. Okay. A lot of people were like, I can figure out the pattern, but I don't know how to put it into words. So again, remember in the beginning and throughout the example, I kept using the word difference. So when I did this one the first time, I said the difference goes up by 2 each time. Okay, and that's true. When I go from 10 to 4 and subtract them, I get 6. When I go from 10 to 18 and find the difference, I subtract them, I get 8. 28 and 18, I subtract them, I get a difference of 10 numbers. Okay, so the difference between the two numbers goes up by 2 each time. Okay, make a conjecture about each value or geometric relation. I cannot read today. Or geometry relationship. List or draw some examples that support your conjecture. Okay, the sum of an even and an odd number. Okay, you need to know what these words mean. What does sum mean? Sum means to add, okay, so plus, okay. Of an even number, hopefully you know what an even number is. It's any number that can divide by 2, so 2, 4, 6, 8, 10, 12. Okay, odd numbers are the ones that don't divide by 2, 1, 3, 7, 9, okay. So let's take a sum of two numbers. So let's do an even. Let's pick 8 and 3. The sum of 8 and 3. So 8 plus 3 is 11. Okay, there's one example. You can't just make a conjecture off one example. I like to give multiple examples to come up with my answers. So what's another example? Give me an even. Let's do 4. And odd, let's do 1. That's 5. Okay, let's do an even. 6 plus, I don't know. Let's do 7. What's 6 plus 7? That is 13. So what can your conjecture be? What can your final conclusion be when you find the sum of an even and odd number? The answer will be what? You should say the answer will be odd. Okay. So I usually do 3 dots. Dot, dot, dot. The answer will be an odd number. Okay, and that's true because we have a whole bunch of examples, okay, and then we came up with our conclusion. Okay, the product of two even numbers. Well, what is product? Hopefully everybody knows what product means. It means to multiply. Okay, so the product of two even numbers. Remember, numbers that divide by 2. Okay, so if you want to separate these, you can. So let's do some examples. Okay. 2 times 2. What's 2 times 2? 4. Okay, let's do at least 3 examples. What is 4 times 10? Those are 2 even numbers. That's 40. Okay, what about 8 and, I don't know, 6. 8 and 6 is 48. So what is a conjecture that you get when you find the multiple of 2 even numbers? When you find the product of 2 even numbers, the answers will be an even number. Right? All right, counterexamples. What do you think a counterexample is? Okay, a counterexample is a false example, okay? It can be a drawing, a number, or a statement, okay? So examples that are false. Okay, So again, it can be a drawing, a number, or a statement. Okay, because sometimes you're going to see it's going to be a lot easier to show in numbers or drawings than it is to actually come up with the words to explain why your statement's not true. Okay. I will give you a few more seconds to copy all that. Make sure. Okay, guys, in your notebooks, I expect you to write everything I write. So whatever I've written down, you need to write down as well. Okay, I don't think I said in the beginning, but if I go into do your notebook check and you not have this in, I will be very, very upset. Okay, examples. Find the counterexample to show that each conjecture is false. So if n is a real number, okay, real numbers are 1 and anything above 1. Okay, that's a whole number. Okay, so that's what a real number is. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 0 counts that as well. Okay, so it has to be positive, has to be a whole number. So what's a positive whole number that will prove this statement is false? If n is a real number, then n squared is greater than n. Okay, that's greater than, the little alligator mouth is eating this one, so this is the greater than. Oops. Okay, so you can plug in whatever you want. Let's try, okay? Is 5, let's plug in 5. That's a real number. Greater than 5 squared? Yes, that's 25. So, okay, well, that's a true statement. Okay, let's see, maybe 3. Is 3 squared greater than 3? Yeah, 3 squared is 9. Well, that's a true statement. We need to come up with a false statement. What would a false statement be? That's a real number, so a whole number that is positive. What about the number 1? Yeah. Is 1 squared greater than 1? No, 1 squared is not greater than 1, because 1 times 1 is 1, and 1 is not greater than 1. They would be equal to each other. Okay, another one is 0. What's 0 squared? Okay, anything 0 times 0 is going to be 0. So 0 squared is not greater than 0. So some false examples would be if n equals 1 or if it was 0. Those would both make a false statement. Those are not true statements when you plug them into the equation. Okay? B. If n is a real number, then negative n is a negative number. Okay? So this one's saying pick a whole number, okay? That's positive, okay? Plug that in for n. And then when you plug that in for n, if it's negative n, it's going to be a negative number. There's only one counter example for this. So like pick any number. Oh no, let's do 9. N equals 9. Well, negative 9, right? Because you're going to plug it into this. All right, that's true. That's the right number. Okay, so that's not a counterexample. That's true. It becomes negative. Okay. Can anybody try to figure out what, again, I like to do 2 correct ones when I plug that into the equation. If n is 5, negative n would be negative 5. That's a real number. I mean, not a real number, but that is something we use in math. What's a number when you plug it in? It's not what you use in math. What about if n was 0? Have you ever seen a number in negative 0? No. Every year I talk about this, that if you go on Apple Maps though, or not Apple Maps, Apple Weather on your apps, on your iPhone, it is so annoying because a lot of times on the days where it's 0, it will say negative 0, and that drives me nuts because negative 0 is not a real thing, okay? You don't write negative 0, you just write 0 on a number line. I've never seen negative 0 on a number line. Okay, so the only one that is a counter example, okay, so this is the counter example. If n equals 0, that is a counter example. That makes the statement false. So when is this false? The first one, if n is 1 or 0. And the second, if n equals 0. All right. Moving on. Okay. A blank is any sentence that is either true or false. So you can make a statement. I can make a statement, and maybe it's true, maybe it's false, okay? If it rains outside, my shoes are going to be wet, okay? That could be true. Maybe you guys can find a way that will be false, okay? So what we do then in geometry is then we come up with, well, is it true or false? We're going to come up with a truth value. Again, you're going to have to write real small. Truth value. Okay? The truth value of a statement is either true or false. A statement can be represented by using a letter, okay? So for example, when I say my statements in geometry, I'm not going to write out a whole long sentence, okay? I'm going to replace it with a letter. So for example, I say statement P, okay? If I say I want to talk about statement P, P actually is going to mean Chicago is a city in Illinois, okay? Is that true or false? That's true, correct? Okay, the truth value of statement P is true. So if I say, is P true or false? You're going to say, what does P represent? It represents this whole statement right here, and that's a true statement. Okay, several statements can be joined in a compound statement. I think in English it's called a compound sentence when you combine and add the word and commas and stuff. So it's pretty much the same idea. This is called a compound statement instead. Okay, compound statement. And how we combine in geometry is conjunctions and disjunctions, okay? We are going to get there in a second. The first thing we're going to do, okay, is called a negation. Okay, negation, a lot of times people think of the word not. You're just going to add the word not and it's going to be all good. I kind of gone away from that because a lot of times my students wanted to add the word not, but what happened if the statement already had the word not? Like, it is not raining outside. Well, the negation would be the opposite of that. It would be, it is raining outside. So again, negations, a lot of time people want to put the word not, but it's actually you write the opposite of whatever is given. Okay? So a lot of times it is adding the word not. Okay? But again, there will be some rare times when they don't, or when you have to take away the word not. Okay? All right, the statement P and not P have the opposite truth values, okay? So if I say the sky is blue, the negation, and that's true, okay? Then the negation, the sky is not blue, would be false, okay? So whatever the statement is, if P is true, the negation is false. If P is false, then the negation is true. Okay, that's important later on. Okay, conjunction, okay? You're going to combine with the word and, okay? Okay. All right. So you're going to use the word and to combine statements. So let's say P is Las Vegas is in Nevada. Then this little up arrow, that means the word and whatever Q is will come after that. Let's say Q is San Diego is in California. So Las Vegas is in Nevada and San Diego is in California. You read it P and Q, or whatever P is, that statement, and then whatever Q statement is. Notice these go in alphabetical order. That's going to be important later on as well. Everything in this lesson builds. I keep being like, that's going to be important, that's going to be important, but it all builds to the very end. Okay? So this is very important if you want to highlight this. Highlight this box right here. Okay? What you need to highlight in here is this word right here, both. Okay? If it's P and Q, it's true only when both P and Q are true. So what I'm going to say now is that you need two T's, okay, to be true. Okay, this is all very, 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 very important. Okay. Oh, it's not even on there. I'm so sorry. Okay. Both things must be true for and statements to be true. Okay. If I said, again, Las Vegas is in Nevada, and then the next statement was San Diego's in Oregon, that's a false statement. The whole thing would be false, okay? Even if P is true, if Q is false, the whole thing becomes false. If P is false and Q is true, and it's an and statement, it's still all false. Both things must be true for and statements to be true. Okay? So what if about disjunction now? So what does disjunction mean? Okay? Disjunction is what you're going to use or to combined. Okay? So how you read this one is P or Q. Now what does or mean? Okay? So if you think or is like this or that, you don't have to have both. Or and, I need both things. This and that. I need both this and that. Or statements, listen to this. P or Q is true if P is true, if Q is true, or both is true. Okay, so if all you need for this one is one T, okay? You need one T for the statement to be true. Okay? So if I said P was the sky is blue and Q was the grass is maroon, okay? If P, so is the sky blue? Yes. Or is the grass maroon? No. But since the sky is blue, P is true, then the whole statement's true, okay? So what's the big difference between and or, okay? And both statements must be true. This and this must both be true to be true. Or you need one of the two things, only one thing, this or that must be true for the whole thing to be true. Okay. Hopefully you guys are not just scratching your heads right now, like I'm so confused. Okay, so what's going to happen is I'm going to give you three statements in the next example. I'm going to give you a P, a Q, and an R. Okay? This one, I want you to write total because right now we're going to use it as a total. Okay? So use the following statements to write compound statements for each conjunction or disjunction. Then write its truth value. Okay, so P right here is that 10 plus 8 equals 18. True or false? Is that a true or false statement? That is a true. Okay. Q is September has 29 days total. Again, we're going to add in the total. Is September 29 days total? No, that's false. It has more than 29 days. Okay. Last but not least, R. What is our statement going to be? R is going to be a rectangle has 4 sides. Does a rectangle have 4 sides? Yes, a rectangle does have 4 sides. I hope everyone knows this. Okay, I try to pick examples that we all could understand. So, write out the truth, write out the statements. On your homework, you are also going to be writing out all the assignments, okay? Or all the statements. I do not want you guys to just write true or false. You will write out the statements, then do the true or false value at the end, okay? So what is P? Okay, we know P is a true value, okay? So you're going to write 10 plus, not 18, 8 equals 18. What's this caret mean? And what is Q? Okay, Q was a false statement, okay? And September has 29 days. Okay, so P and Q written out in word form would be 10 plus 8 equals 18, and September has 29 days. Okay, as a full statement, is this whole thing right here true or false based off the conjunction, disjunction information? Okay, so remember, and statements, 2 T's must be to be true. Do we have 2 T's right here? No. P is true, but Q is false. So the whole statement is false. Even though P is true, the whole thing must be true for it to be true on an and statement. So since this part is false, the whole thing becomes false. Okay, let's do the next one. Okay, P, we just did P, we know that's true. So 10 plus 8 equals 18. That's the statement from up here that P represents. Okay, let me fix my thing, sorry. Okay, what does this down arrow or this down caret mean? Or, okay? Or, and what is R? R is right here. Okay, we already know R is a true value. Or, a rectangle, okay, has 4 sides. Okay, so on OR statements, how many T's do we need? We only need 1 T. Do we have at least 1 T between these two statements? We do. So this whole statement is true. Okay, so again, when you look over here, you only need 1 T for OR. You need both T's for AND to be true. All right, so here we come to this little negation right here, okay? It says not Q. Well, let's go back to Q. What was Q? September has 29 days total. So this means not Q. So if the original Q was false, right? The original Q was false, the negated would be true, okay? Then we have an OR statement. In R, we already know from right here, R was true. So right away, you know the whole thing's going to be true. Okay, but let's write it out in words as well. So how would you negate, how would you write the opposite of Q? September has 29 days total. Okay, you don't need to change the whole sentence. All you're going to do is September, okay, does not have 29 days. Or, and then you're going to write the R statement because it's the opposite of Q or R. Okay? Or a rectangle has 4 sides. Okay, and again, we've already found it's true because on OR statements, we only need 1 T for the whole thing to be true. So again, on your homework, this is what I am looking for. This is what I am looking for. I would like you to write out the full statements, because if I have negations, you need to practice writing out negations. And then I want you to tell me if each piece is true or false and what the final verdict is for both statements when they're put together. What the compound statement is. What is the compound statement? In this case, we only needed 1 T. We have 2, but we only needed 1, so the whole thing was true. All right, last but not least on this page, what was P? P was 10 plus 8 equals 18. That was true, 10 plus 8 equals 18. This is right here, this is an and. And, okay, now we have R, but it's not R, it's not R, it's the negation of R. So R was true. So the opposite of R would be false. So how would you write the opposite of the statement of R? If it says a rectangle has 4 sides, the negation would be a rectangle does not have 4 sides. And again, that is a very false statement. The property of a rectangle is that it has to have 4 sides. It's quadrilateral. So if the first part's true and the next part's false, what's the compound statement? Is the whole thing true or is the whole thing false? The whole thing would become false. Again, because and statements need both things to be true. And since one thing's false, the whole thing becomes false. All right, backside. Hopefully this doesn't take us as long. Let's flip over our papers. I want to flip over mine as well, my key that I'm following. All right, one way to organize the truth values a statement is in a, kind of funky truth table. So what is a truth table? A truth table is just a super awesome way to organize all of your thoughts because, yeah, I can give you a statement like the sky is blue, okay? You can tell me that's true or that's false. That's easy to do. But what's going to start happening is you're going to get multiple things put together in one compound statement, and you have to decide what's the truth and false values of each thing based off different scenarios. So again, it's just a way to organize, okay? So let's look at the first one, okay? I give you one statement. I give you P. I say, right now the sky is blue, okay? You look at me, you say, okay, that could either be true. Let's go look outside. Is it true or is it false, okay? There's your organization. There's two options. The sky is either blue right now or it's not blue right now. If I said, okay, now negate that statement, okay? Remember, whatever this is, the negation is the complete opposite of it. So if I said, the sky is blue right now, okay? What would be the negation? The sky is not blue right now. Well, if it is blue, then the original was true, now this is false. But if the sky was cloudy and it was gray, then the negation is true, because yeah, the sky is not blue right now. Okay? So again, you create, everything has two options, true or false for each statement. Okay, and the negation are just what's the opposite of that. Okay, this is where it gets a little tricky. Now I'm going to give you two statements, okay? The sky is blue right now. I own a red car, okay? So what happens is both statements can be true. The sky could be blue. I could own a red car, right? And remember you have to have for an and, this boy right here, both things you need two truths, okay? For it to be true, because it's an and. Okay, sorry, my nose is already. So, the sky is blue. I do own a red car. Both things are true, okay? But what happens if the sky is blue, but my car is not red? I think I said red. So, not red. I have a yellow car. Well, and statement, since they are both not T's, then the answer is false. Okay? What if it's cloudy outside, but my car is red? Well, there's not two T's here. We need both things to be T for this to be T. Okay? And lastly, the sky is not blue, it's gray, and I own a blue car. So if both things are false, then everything's false. So this is where I think it gets a little bit crazy. So what I do, when I start organizing, whatever is here, I find that table and I highlight it, okay? So this is where the highlighters come in play. So I need P and I need Q. So I'm gonna highlight those two because those are the two tables I'm gonna be using. Again, this gets wild in a little bit, okay? Okay, same thing, we have disjunction, it's gonna be the same as before, okay? This is an or. So an or statement, we only need one T, right? I know I did double T, like Texas Tech. Okay, you only need one T for the whole thing to be true. So I'm using this P right here, so I need this table. I'm using Q, so I need this table. Make sure you're highlighting. Okay, so again, P is the sky is blue. This time it's an or statement. Or I own a red car, okay? If the sky is blue and I own a red car, obviously everything's true. It's or, okay? If the sky is blue, but I own a black car, that's fine. As long as one thing in this row right here is T, this statement's true. Again, that's on an or statement, okay? The sky is gray, but I do own a red car, okay? So do I have at least one T in this line? Yes, so that's true. And lastly, the sky is gray, I own a black car. Both things were false. So look at the difference between these two. I know it sounds crazy, but you look at this to determine this. You look at these two to determine this one. You look at these two to determine this one. You look at these two to determine this one. And two T's or one T. All right, here it goes. Get ready for it. These are the rules. You must do these rules every time, okay? Letters must go in alphabetical order. So if statement is PQR, you can't go RQP. You must go PQR. If you have ABC, you must go ABC. You can't do CAB. It will not work. You need to go in alphabetical order as the statements are listed. Okay. The formula determines how many rows you need. Row means like how many of these you start with, okay? Is 2 to the number, raised to the number of letters, okay? So an example, I'm just gonna zoom out because you guys can read. Make a truth table with P, Q, and R. The rows you need to start with is 2 to the third because you have 1, 2, 3 letters. So you will have 8 rows total. Okay? Those 8 rows, we're going to get to it, but, well, like it says right here. I'll wait till I get there. Okay, only compare 2 columns at a time. A column is where we drew our little arrows to right here, where the highlighter went to. So we compare these 2 columns to understand this column. You can only compare 2 at a time. You can't compare 3, 4, 5. You're only going to compare 2 true and falses at the same time, every time. Okay, the first column. The top half rows are T and the bottom half rows are F, okay? Let me see if it's on here at all. Okay, kind of. So in this case, okay, we had P, we had Q, we had R. Okay, the top half, so you're going to do 8 rows because again, we have 3 letters, P, Q, R. So 2 to the third equals 8 because 2 times 2 times 2 is 8. Got it? It's not 2 times 3. It's not 6. It's 2 to the third. It's 2 times 2 times 2. So the top row of the 8 rows are going to be true. So what's half of 8 is 4. So you would do 1, 2, 3, 4. The bottom half would be all F's. False, 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 false. Let me write. I don't even like the way that's looking. I'll do it over here. Do we have room? A little bit. Okay, P, Q, R. I'm not going to go on past that. So again, I said the top ones are all true of the 8. So the top 4, then the bottom 4. Then the next row, you're going to split it in half. So what's half of 4 T's? 2 T's. You'll go 2 at a time. So T, T, F, F, T, T, F, F. In the last row, what do you think happens the last row? If this was 4, this was 2, the last row is always going to go by ones. T, F, T, F, T, F, T, F. Now this is very unorganized, but, okay. Then like these should be in line. Got it? It's a lot. Okay, so again, the top ones are all T, the bottom ones are all F. Then you do, instead of 4 and 4, you do 2, 2, 2, 2. The last one goes 1, 1, 1, 1, 1, 1. Okay. So, this year we're supposed to incorporate like these discussions. So our discussion for this part is, what's the big idea? What's the big idea? Why is the number in the formula, why is there 2 here, the number of letters? Okay. Why is it 2? Why is it not 3 or 4 or 5, 6, 7, 8, 9, 10? Well, it's 2 because there's only 2 options. Your statement's either going to be true or it's going to be false, okay? So what's the 2? The 2 is the number of options. That looks wrong, but I think it's right. Okay, options, okay? Which there is only 2 which are true and false. That's why it's 2 raised to the number, okay, of letters to determine how many rows you have. Okay, because the letters are going to change. You might have 2 letters, you might have 4 letters, blah, blah, blah. But you are only going to have 2 options for each letter. Okay, 2 is the number of options, which there is only 2 which are true and false. All right, here we go. So I've set up this one for you, okay? So this one's the final answer. The final question is always going to be in this last column, okay? Columns go up and down, rows go from side to side. So in our final question, this is the final question. It says Q or R, right? So how many T's do we need? Okay, we only need one T first off. Okay. So what we did is I did how many letters do I have to raise to the 2? Because we have 2 letters. So that means I need 4 rows. So I created 4 rows. 1, 2, 3, 4. The top half I made T. The bottom half I made F. And then 2 divided by 2 is 1. So the next column goes 1, or T, F, T, F. Okay? So what's going to happen now is I'm going to take my highlighter. Everybody should take their highlighters. You draw an arrow to Q and you highlight that. That's the first guy you're using. Then you go to R, highlight it. That's the second one. Okay? Going across, again, since it's an OR statement, we only need one T. So going across, do we have one T? Yes. The next one, we have TF. Do we have at least one T? Yes. Do we have at least one T? Yes. Do we have one T in this row? No. So that's false. So if you say yes, you write a T. If you say no, you write an F. Okay? So here's a good example where it gets a little bit crazy, right? So we have 3 letters to start with. P, Q, and R. So the first thing you're going to do, that's what I want you to focus on. Set up your letters first. Whatever letters are in this final statement right here. Okay, whatever's in this final statement right here, that's how you know how many letters you need. So in our final statement here, we had 2. This one has a P, a Q, and an R. So how many letters is that? That is 3 different letters. Negations do not count as different letters. They're still the same letter. They're just the opposite of whatever that letter is. So what you're going to do is you say 2 to the 3rd. Okay, because we have 3 different letters, and that is 8. So I created 8 rows. The first one I did all T's, and the bottom half I did all F. Divide that by 2. Then I did 2 T's, 2 F's. 2 T's, 2 F's, and that's column Q. The last statement R, again, the last one should go 1, 1, 1, 1. So TF, 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 TF. All right. This is where you need 2 highlighters. You're going to need 2 highlighters this time. All right. Here is actually the steps I want you to follow. Okay, so you're going to look at the final statement. You're going to write any letters you see alphabetically. So we did that. P, Q, R. Okay? Then you're going to say, look at this statement. Do we have any negations? No. So we skip step 2. Go to step 3. Write anything inside a parenthesis. So do you see how this has a parenthesis right here? This QR. You are going to write that parenthesis right here. So anytime you see a parenthesis, you're going to make its own column for that. And lastly, you'll write the entire statement. So this one wants to know. Write a truth table for a statement that is P and Q or R. So when do you have a true and another true with one of these 2 things in it? It's a lot. So again, we set up our first table, P, Q, R. We did our letters. We wrote them out, 4 T's, 4 F's, 2 T's, 2 F's, 2 T's, 2 F's, then individually. Okay, get a highlighter. Everybody grab a highlighter. Go to Q. Highlight Q. Draw an arrow over to Q. Highlight that whole thing. What other letters in this parenthesis? R. Go to R. So for this column right here, you can only compare 2 columns at a time. Okay? So this says Q or R. So what you're going to do is you need 1 T for this one, right? You're going to go across. Do I have 1 T between these 2? Yes. This one? Yes. Do I have 1 T on the next one? Yes. Do I have a T here or here? No. So that one's false. T here or here? Yes. T here or here? Yes. T here or here? Yes. The last row, no. So we only have 2 falses, okay? Only 2 times is there no T's at all, right? All right, grab a different highlighter. Everybody needs to grab a different highlighter. I hope you guys are all doing this with me. Everybody grab a different highlighter. Okay, in this final statement, this one right here, these parentheses is going to be this table right here. And you're going to use this one. So whatever the parenthesis is, use the parenthesis column. What's the other one we need? We need P. So I'm going to draw a highlighter over to P and use this. So now we're only comparing the reds, and we have an and statement. So we need 2 T's for this column for it to be true. So going across the first row, we have T, T. So that, do we have 2 T's? Yes. The second one, do we have 2 T's? Yes. The next one, do we have 2 T's? Yes. The next one, do we have 2 T's? No. Okay. The next one, do we have 2 T's? Nope. We have TF. So that's going to be false. Notice the rest of these have false, true. So that's false. False, oh, false, true. So that one's false. False, false. That one's obviously false. So in the end, the only times we have 2 T's are the first, the second, and the third row when we're comparing the 2 red columns. So that's what we're doing today. That's like the final idea. So what it is, again, figure out how many letters you have to determine how many rows you're going to have. We had 3 separate letters. We had P, Q, and R. Okay, so I did 2 to the third, which knows is 8 rows. The top half is T's, the bottom half is F. Then you split it, and you do 2, 2, 2, 2. Then you do 1, 1, 1, 1. You fill out all of that. We had no negations. We had parentheses in the final statement, so I did a parentheses column. Then lastly, I wrote the entire end statement and solved. It's a lot, I know. All right, so we're going to work on a few together, okay? You're going to have to write small because this one needs more room than I thought you did. So in the last one, we're going to take up literally all the space over here. So write small. So we're doing a P or statement, okay? Sorry, P or R. Okay, so how many letters do we have? We have 2. For our final statement, we have 2 letters in our final statement. Okay, what are the 2 letters? We have P, we have R. Okay, do we have any negations? Let's go back to the rules. I wish I would put the rules here. Do we have any negations? No. Do we have any parentheses on this one? Where'd it go? Do we have any parentheses? No. So then we can do step 4, which is write the entire statement. P or R. Okay, so how many rows will we need? How many individual letters do we have? We have 2 individual letters. So we need true and falses for 2 individual letters. So that is 4 rows. So we are going to do 4 rows. What will the top, so this should have 1, 2, 3, 4. Again, the top, what's half of 4? 2. So to the top 2 will be true. The bottom ones will be false. Okay, for R, okay, you can have true, true, right? True, false, false, true, false, false. Okay, so you're creating options. Both are true, one's true, one's false, this one's true, or they're both false. That's all the combinations you can have. That's what you're doing. You're creating how many combinations. So in the other ones, you had 8 combinations total. This one, so again, the top 2 true, the bottom one's false, and then every other one. So get out your highlighters. We need P, so go to P, I highlight that one. Or R, go to R, highlight this one. It's an or statement, so I only need 1 T for it to be true all the way. So do we have 1 T this way? Yes. I almost wish I could just write like T. Okay, do we have 1 T going that way? Yes. Do we have 1 T going across this way? Yes. And lastly, 1 T here. No. And this is your final answer. TTTF. So on a test, this is what I need to see for it to be correct. Okay. So what are the chances, all this is saying is that if I want P or R to be true, either or, how often does that happen? 3 of the 4 times it would happen. One of the statements would be true. Remember, and is both are true, or is just one has to be true. Okay. How many letters do we have? Okay. How many letters do we have? We have 2 letters. We have Q and R. So we need 4 rows. The first row will be Q. The next row will be R. Okay. Do we have any negations? Yes, we do have a negation. Where do you see the little squiggle? With R. So I'm going to do a not R row. Okay. Do we have any parentheses in this statement? No. So we skip that step. Do we have a final statement? Yes, we will always have a final statement. That final statement wants Q and not R to be compared. Okay? Since it's an and statement, we need both of the things to be true for that final one. Okay, we've already decided each column will have 4 rows. So in the first one, 4, what's half of 4? 2. So you'll do 2 trues, 2 false. Okay, the next column right next to it, the R statements. Again, if this one's true, you could have true, true as an option, true, false, false, true, or false, false. So it's T, T, F, F, T, F, T, F. All right, this is where our highlighters come in. So the first one we have is not R. I never really deal with this part until I get to this. This is when I start using my highlighters. So not R, do we need the Q column for that? No, we just need to know what R is and do the opposite. So negations only use 1 column. So not R. So if I go to this column, what's the opposite of each line? So if this is true, the opposite of that would be false. If this is false, the opposite of that is true. If this is true, the opposite is false. And lastly, if this one's false, the opposite of that is true. And that column is all done. Okay, grab a different highlighter. For our final statement, what do we want? We have an and, so it needs 2 trues. And the and is using only Q, so this column, and the not R column. So this one right here is the one that one wants to use. So we're not using the red at all anymore. We are only using things highlighted in yellow. Okay, so we need 2 trues for the yellows. The first row, we have TF. Is that both T's? No. Are the second row, are they both T's? Yes. Are these both T's? No. Lastly, are these both T's? No. So that's false. So if I asked you what the final answer would be, this would be your truth table. That's what it needs to look like. False, true, false, false. Because the only time both things were true was the second row. Okay, there's only one time. All right, here we go. Hopefully, like I said, you guys saved your room because you definitely need it for the next one. All right, how many letters do you see? Let's start there. How many letters do you see? We have P, R, and Q. So we need true or false for 3 letters. So that's 8 rows. So next to this, I'm going to do P. Remember, write small. Please, please, please. P, Q, R. Okay? Notice, this goes P, R, Q, but is that alphabetical? No. Letters must be in alphabetical order. Okay, we have 8 rows. If you want to do those right now, you can do those right now. Okay, I'm going to go there in a second, though. Okay, the next step. What's the next rule? If you don't remember, it's right here. Write any letter with a negation. Do we have any negations? No. Okay, What's step 3? Write anything inside a parenthesis. Do we have a parenthesis? Yes, we have P and R. Okay, that's the only parenthesis I see, so we're good there. So what's the last step? Write out the whole thing. P and R or Q. All right. So again, 3 starting letters means 8 rows. The first 4 on this one, the top half are T's, the bottom halves are F. Okay. The next one, if this is 4 T's, 4 F's, the next one goes 4 divided by 2 is 2. So 2 T's, 2 F's, 2 T's, 2 F's. Again, because on this last one, it's going to go T, F, T, F, T, F, T, F. Because this is all the combinations you can have total with those 3 letters. You're going to have all true, the first 2 true, then false, true, false, true, true, false, 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 true, true, false, true, false, 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 true, or false, false, false. That's all the options. That's why we're organizing it in a truth table, because that's so many options. Okay, grab your highlighter. Okay, this is P, so I'm going to go to P, highlight that column. And, because that's an and, right? R, so I'm going to go to R, highlight R. And means we need 2 T's. So you're going to go across the row now and say, do I have 2 T's? Yes. 2 T's? No. That's enough. 2 T's? Yes. 2 T's? No. 2 T's? No. FF, FF, FF. So the only 2 times that we had 2 T's, because it's an and statement, you need 2 T's, was the first row and the third row. This one right here and this one right here. All right, last but not least on this one. Okay, grab a different color. I'll do purple this time, that's fun. Okay, again, once you have a parenthesis, you have a column for this whole parenthesis. That one is this one right here. Here's the parenthesis column. So I'm going to highlight this one or Q. So I'm going to go to Q, highlight Q, and highlight all of Q. Again, you can only do 2 columns at a time. Okay, so then we have this symbol. What's this symbol? Pointing down is or. So how many T's do we need to write a true? 1 T. As long as you have 1 T, you can write a T. The first one, we have T, T, so that's true. Then we have TF. We have at least 1 T. Do we have 1 T? Yes. 1 T? No. 1 T? Yes. 1 T? Yes. 1 T? No. 1 T? No. So this will be your final answer on a test. How many options are true? 1, 2, 3, 4, 5. Okay, and 3 times it would be a false. All right. Whew. Okay. Hopefully this is making a little more sense. So this is a long lesson, I know. All right, last one. Okay, you have how many letters? 3. So I have 2 options for 3 letters. That's 8 rows. What's our 3 letters? Let's set up quick. Actually, I'm going to do it probably over here, okay? So our letters, because I have more room. We have P. We have Q. We have R, okay? Do we have any negations? Yes. I see one right here, not Q. So I need to know what not Q is. Told you it's a lot. Okay. Do we have a parenthesis? Yes, we have a parenthesis. It's not Q or R. And lastly, you're going to write out the whole statement. Okay? What's the whole statement? The whole statement was P and the parenthesis, not Q or R. Told you it's a lot. This is what your table looks like. Okay, this time you need 3 highlighters. 3. Okay, so how many rows did you need? Again, it's right here. We need at least 8 rows. Okay? If you need 8 rows, the top 4 are T, the bottom ones are F. Okay? If this is 4 and 4, that means these go by 2s. So TTFF, TTFF. This last one goes 1 by 1. So TF, 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 TF. And those are all the possible combinations you can have with those 3 letters. Okay, grab your highlighter. The first row, what do we need to find? Not Q. So where are we going to look? If we want not Q, are we going to look at P or R? No. We're going to go to Q. Say, what is Q? Find the opposite of that whole thing. So if it goes TTFF, TTFF, the opposite would be FF, T, T, F, F, T, T. Sweet. Okay, scooting over, grab a different color highlighter. I'm going to do yellow. Oop, I forgot to close this parenthesis. There you go. What do we need for the yellow? We need 2. The only time you use really 1 column is when you do negations. Every other time you should be using 2. Okay, this one needs not Q. So where's the not Q? Right here. Okay, or R. So we're going to go to R. So we haven't used P yet, and that's okay. This one we're only comparing the 2 yellow columns. Okay, and the arrow is pointing down. So how many truths do we need? We only need 1 T. Okay, do we have 1 T in the yellow? Yes. FF, so that's a no. Do we have 1 T? Yes. Do we have a T? Yes. Do we have a T in that row? Yes. FF, nope. TT, yes. FT, there's still 1 T, so we're good. Okay, last one, grab a different highlighter. Again, this is why you have to have 3 highlighters today. I told you get 3, hopefully you have 3. Okay, this one wants P, so I'm gonna go to P, find P. It wants the P, okay? And then it says use the parenthesis one. Well, here's the parenthesis column right here, okay? So this is this one. This one is all over here, okay? So for the last one, here we go. And it has an upward facing arrow, so that's an and. So both things have to be true for it to be true. So we have TT, are both true? Yes. We have TF, no. Okay, the third, it's kind of hard to see, so if you need to go like this, each one. Okay, the third is TT, so that's both true. Okay, then we have TT, okay, so both of those are true. Okay, what are we on, the 5th row? The 5th row is FT, so that's going to be false. Notice the rest of these are Fs, and since we need both of them to be true, it's going to be false. So false, false, obviously it's going to be false. 2 T's, no. 2 T's in the green, no. So on a test, this would be the correct answer for if I said create a truth table. Okay, so this one has all the steps in it. So it has all 3 letters. Okay, 3 is the max amount of letters I'm going to give you on this unit. Okay, I put them in alphabetical order. I did any negations. I had a not Q in my final thing. So I did not Q. I found Q, did the opposites of it. Then I wrote out any parentheses I see, which was at the end right here. I wrote it out. Okay, I used the not Q. I highlighted that in yellow. And then I needed R, so I highlighted R in yellow and compared the 2 R columns to get this guy. And lastly, to find the final answer, I used P, so I highlighted P in green, and the parentheses right here, and highlighted those to get my final answer. Okay, what is important? I mean, if you guys can fill these out yourself, talk with your partner. Okay, what is the most important rules, patterns to remember from this topic? Okay, this could be anything. It could be go alphabetical order. It could be that it's always 2 raised to the number of how many letters you have to find out how many rows you have. Like, you and your partner decide what was maybe the biggest struggle you have, okay? And write those down to help you remember, okay? The little dot Z thing over here, this just means like pattern. Lastly, this is like general ideas, like where can you find this else? Where have you seen these patterns from the truth tables used in the real world, okay? Real world examples is a lot of times, like if you're playing cards, you have a red and a black card. Okay, it could be a true or false. What else? When you flip a coin, okay? When you flip a coin, there's 2 options. There's heads, there's tails, okay? So anything like that. So again, what rules do you want to remember, okay, to help you solve for these tables? And lastly, what are some of the patterns based off this? Like, when have you seen this in the real world? Okay, last thing. The next thing you should be doing, oh no. All right, sorry. Okay, the last thing you should see is this, you're going to receive an assignment. It's called the 1.2, okay, inductive reasoning practice. Okay, this one you're just making conjecture, just like we did in the notes in the beginning. You're going to say, like, what's the conjecture? This section right here, okay, that is how we did this section, okay? You need to say if it's true or false and write it out. If you just do this part right here, you're not getting the points. Got it? Okay, well, how do I write knots and stuff like that? Okay, so like if you need to write the opposite of this one, let me see. How I can, oh, I can't draw it. Okay, let me see. Okay, let's see if it goes there. Okay, so if you need to write S, okay, if you need to write not S, you would not, how do you make this a not statement? This says -8 minus 3 equals -5. You would say -8 minus 3 is not equal to -5. That's been like, every year people are like, I don't know how to write that. Okay, what about this one? 2 plus 8 is not greater if it's a negation. A continuous line, a line continues indefinitely in only one direction. A line does not continue indefinitely in one direction. -3 minus 2 is not equal to -5. Those are the negations. Every year people struggle with those. It's kind of just funky. Okay. And then I have set up your truth tables for you on this page. Again, find the not P, fill it out. Fill out, use not P, use Q, solve for it, and then do the not of this not. So the not of this parenthesis. So I would use this parenthesis, fill out this not. Okay. Again, find not P or Q. Okay. Highlight the ones you need, which are only these 2. Finally, you'll use P and not the parentheses. So the last one, you should use this table and this table. Here's those steps if you need them again, right here on the back side. And there is all of that. This one's large, okay? If you get stuck, please come see me on Thursday. All right. That's it. I hope you guys have a great day. I'm sorry, this was a super long video. All right. But I will be back tomorrow, and I hope you guys have a great day, and hopefully some of this makes sense. Bye.